In this presentation, we're going to be talking about how the functional anatomy of the central nervous system is affected by the fluid that covers it and is within it, how it's affected by the membranes that cover it, and also how it's affected by the bones that cover it. So, as you all know, the central nervous system is composed of the brain and the spinal cord. So let's draw a brain and a spinal cord. We'll start with the cerebral hemispheres, like that. And here's another one. Here's the temporal lobes. And the spinal cord simply extends down from the brain, down like this. So it all looks fairly simple. And it's all one thing. So the brain and the spinal cord emerge imperceptibly. Now the thing is, where the brain stops becoming the brain and becomes the spinal cord is where it pokes out through a large hole in the base of the skull called the foramen magnum, which we've drawn just here. And the bony covering will be continuous with the skull around the brain, like that, right away down to the foramen magnum. And then from the foramen magnum, we've got a series of articulated bones, joints, which correspond to the vertebrae. And so these provide a nice protection to the central nervous system. There we are. I'm going to draw this all the way down. There. The second thing that we need to remember is that within the skull, there are membranes, partitions, that extend from the inside of the skull down here like that, coming around, and then there's another shelf that'll extend in here, and another one that comes around like this, and then it starts to cover the spinal cord and actually goes all the way down to the bottom end of the spine, which I'll draw like this. So let's continue this on. This corresponds to the dura mater, which literally means the hard mother. Right. Okay, now let's draw this one in here. Now these dural extensions have got names. This is the falx cerebri, and this would be the transverse bits of the tentorium cerebelli that help to support the brain. One thing to remember is that this pink structure here, this dura mater, is attached to the inside of the skull all the way around here. But then when it extends into the vertebral column, it's pretty much free to move, and that's so that you can nod your head and so on, and the spinal cord can move up and down. Just underneath the dura is another layer, and let's find a different coloured pen. Let's go for yellow. And this is called the arachnoid layer. Okay, and it follows the dura, and it follows this sort of area around here. Underneath this yellow area is a region of fluid. It's in the subarachnoid space, and the fluid that you've got, let's draw it in here, is called cerebrospinal fluid. Yeah. So that's going to surround the brain and support the brain because the fresh brain and the spinal cord has got a consistency a little bit like cold custard. You imagine what it's like to pick up cold custard. So we need to support it. We've got the hard mother, the dura mater, helping to support the brain. And then we've got a bony covering, which is not going to stretch, so it's going to be protective of the brain. And then we've got the vertebrae of the spinal cord. So in here, we've got cerebrospinal fluid just underneath the dura and just underneath the arachnoid, just above the brain. And this continues on around the spinal cord. Let's find the right colour pen. And can you see we've got a bit of a gap at the bottom here between where the spinal cord ends and where the dura mater ends, which goes all the way down to the bottom end of the spine to about the fourth sacral vertebrae. So in here we've got a pool of cerebrospinal fluid down at the bottom end. So the CSF, but there isn't any spinal cord, and that's quite useful clinically. Okay, So we're allowing the brain and the spinal cord to float in CSF, which is a bit like dilute plasma. And because we're not attaching the dura, this is the pink substance here, to the bones too much, we're allowing the spinal cord to move, so I can nod my head forwards and backwards. As I nod my head forwards, my spinal cord moves up just a little bit and moves down. And then we've also got some fluid at the bottom. There's also some fluid right in the center of the brain as well, about here and a bit in the middle. So we've got some CSF floating around inside the brain. Eventually it is secreted onto the outside of the brain, and it flows all the way around here. Okay. And this leads me to an important point, which is that the spinal cord in the adult doesn't actually extend all the way down the spine. So it's commonly thought that it goes all the way down your spine. And in fact, it ends at about the junction between the first and the second lumbar vertebrae. So if we drew a little diagram of a person viewed from the back, so here's their neck. Let's try and get this right. Okay, and their arms, and there's their back. There's the rest of their arms just here. Let's draw a waist like that. Let's draw the buttocks like here. We've got a couple of dimples that you can generally see in terms of surface anatomy. They correspond to roughly the position of the second sacral vertebrae. And if you feel the tops of your hips as well, draw a little line across, that's about the level of the fourth lumbar vertebra. And the other thing you can see in surface anatomy are the ribs at the back. And if you find the last rib, which is here, that's going to take you up to the 12th thoracic vertebrae. The place where the spinal cord ends, believe it or not, is not far from where your ribs stop. So X marks the spot, just there. So this is this junction between the first and the second lumbar vertebrae, which means if you break your back and fracture the bones down here, most of the lumbar and all the sacral vertebrae, you'll not actually damage the spinal cord. But there's another important point here. Remember that I pointed at this area here and said there's a pool of CSF, which is certainly below the L1, L2 region. It means that we can put a needle, usually between the third and the fourth vertebra, in here, and we can sample the cerebrospinal fluid. And that's important because if you think that something has gone wrong in the brain, perhaps there's been a bleed, or perhaps there's an infection, and so there might be blood in this cerebrospinal fluid, or white blood cells or bacteria. It'll also be present in the CSF down the bottom. And it's a lot easier to put a needle in here where there's no CNS to damage than it is to stick a needle into one of these ventricles, because you cause an awful lot of damage. So this is a procedure called a lumbar puncture or a lumbar tap. Okay, and I think we'll probably leave it just there for a moment.